Hello everyone and welcome to the Circular EcoBIM podcast series. My name is Verena Göswein and it is my great pleasure to moderate this podcast. The podcast series is part of the Circular EcoBIM project. The project is developing a platform that makes use of building information modeling to improve the circularity of new and existing buildings, considering their life cycle impacts. The project is funded by EEAGrants and developed by different entities from Portugal and Norway. As our objective is ultimately to improve the sustainability of our built environment, we are making use of this opportunity to connect with different experts that are working towards that same goal. In total, we produce 4 podcasts where we discuss different topics of the circular economy, buildings, and the construction industry. In each episode, we have one guest from the Circular EcoBIM Project Consortium and one external guest. Today's topic is metrics for circular construction. We will discuss how to source, manage, store, and analyze data of materials and buildings. According to the principle, if you can't measure it, you can't manage it, we will talk about where to get and how to collect relevant data, how to do when data is missing, and how to manage data over time, as well as about future opportunities arising from digitization and other trends. I have with me today Rolf André Bohne and Eirik Resch. Rolf is a member of the Project Consortium, an expert of sustainable buildings, and a professor at NTNU. Eirik is our external guest today. He is an expert of life cycle emissions of buildings and sustainable cities and has published numerous papers about building material emissions. But before I let my guests introduce themselves, just a couple of words about myself. I'm the technical project manager of the Circular EcoBIM project in my role as a senior consultant at 3 Drivers, a sustainability consultancy in Lisbon. Moreover, I am a postdoctoral research associate at the chair of sustainable construction at ETH Zurich. My background is in civil engineering, but I'm mostly interested in interdisciplinary approaches of climate change mitigation. So, welcome. Thanks for being here. Would you maybe like to introduce yourself?
Yes, welcome everybody. My name is Rolf André Bohne and I'm a professor at the Norwegian University of Science and Technology. My background is natural science, but I've been working on material flows and environmental impact from the built environment since 2000. And I have a PhD in industrial ecology from NTNU. So mostly I'm working on environmental impact assessment of buildings and infrastructure.
Thank you so much, Rolf. I'm very excited to have you here. Eirik, do you want to do the same?
Yeah, hi. Thanks for having me. My name is Eirik Resch. I'm a researcher at the Norwegian University of Science and Technology. My background is in natural sciences, where I took a degree in physics and then pursued an industrial ecology degree after that. So I can say I have expertise in natural sciences and also environmental assessment. Then I followed up with a PhD in applied mathematics combined with architecture and computer science. So that's my technical background, and research that I've been doing revolves around the carbon footprint of buildings and construction projects. And I have developed some methodologies for improving those assessments. On the side of my research, I also founded a company 1.5 years ago, which is called Reducer. Reducer develops a software for performing these carbon assessments of buildings. So that's the applied part of my work.
That's great. I think it's very nice that you're with us today to tell us more about both the theoretical and the practical side of all of this. So maybe let's start. First topic on the agenda today is collection of data. Maybe just a couple of words before, why are we talking about all of this? When we speak about sustainable buildings or circular buildings, what we usually mean, at least when we refer to environmental impacts, is that we want to reduce the environmental impacts over the life cycle of the building. And that also includes the end of life of a building. Meaning what happens once the building is demolished, or in a better case, deconstructed. Is there something we can do with the material, for example, for reuse, or can we recycle some of these materials? on-site, in another building, or for a different purpose. And there's different methodologies and concepts that have evolved around all of this. Worth mentioning is definitely the circular economy that wants to move from a linear to a circular use of materials. And this can also be applied, of course, to buildings to minimize construction and demolition waste. Another thing that seems worth mentioning is life cycle assessment. That's a standardized method to analyze the environmental impacts related to building construction use and end of life. But of course, it's a quantitative analysis, and as such, it requires lots of data and lots of information about the building, all its components and materials. And that's where we start. So could you maybe tell us a bit about how do you use data and what kind of data do you collect?
So collecting data is in this field has been traditionally kind of problematic because a lot of the time the results are published without all the background data. So it's not common that the studies are fully reproducible. And that's been part of my work to kind of try to promote publishing all the input data for these carbon assessments and then organizing them in a structured database so that based on those input data, we can recalculate the assessment with any methodology. So the methodological differences in system boundary and calculation methods, so they would work for any previously performed study. So where to get that data from? Most of the time, the building owners or the environmental consultants will be sitting on this in industry, and in research, it's the researchers which would have that data. So there is a lot of data available, but it's not centralized. It's not available to everyone. So the struggle is maybe to kind of get a common platform or a common format to share this data.
Well, this is a kind of, what Eirik mentioned is a big problem, because traditionally, if we go 100 years back, we had like 50 defined different materials entering constructions. And today we have something north of 75,000 product names, each of them with their own secret recipe. And secret is a key word here, because they don't really want to distribute these data that we need for these calculations. And the other thing is that is problematic when we're doing the calculations is the kind of service life. Eirik mentioned it briefly, but kind of different products in buildings has different lifespans. So in the end, we don't really know these things. And this is really difficult when you want to compare different materials in buildings, because okay, you might get the data, but from somewhere. As Eirik said, these are often in the hands of the consultants, and there is a lot of economic kind of incentives to not distribute these data evenly or openly. So this is a big problem in order to select this. And then you also have small, maybe very good producers of something that can't afford to make an EPD of things. Mm-hmm. There's a huge variation here, and it's difficult to find data. The calculations are not so difficult. To get good data is difficult.
Mm-hmm. Yes, you mentioned a good point, which is maybe that some manufacturers don't have the means, or maybe also the aspiration, that would be my question, to invest into creating open information about the environmental impacts of their products. Is that something that you experience and that you see as a challenge at this current moment in time?
Definitely a challenge. I mean, if you ask a paint producer to give you data, he will refuse because yes. By the time he is giving us the data, the competitor is able to kind of decode his recipe. Uh-huh. So he would lose his competitive advantage, which is what is hidden in the paint. For smaller producers, there's both. There are those who are very forward-leaning but can't afford it. And as you said, there are those who are not forward-leaning that want to hide it. But I think most of them, at least where we are here in Norway, they are doing something in wood, so they are not really reluctant to do so. They just don't have the means to do it because it costs too much, both time and money.
Mm-hmm. Could we maybe talk again about system boundaries? Could you maybe try to summarize why this is problematic and what we need to pay attention to when we run an analysis and we use data that's maybe not specific to the context or to the product that we're analyzing?
You could start with what is a square meter. It's utterly difficult. You have many different definitions of what is a square meter of building across Europe. Is it heated, not heated? Is it inside the wall? Is it outside the wall? I mean, to just agree on something that simple would be very...
Yeah. So I think we can distinguish between the material level, product level, and the building level. So there are kind of different issues with those two. For the product level, the manufacturers won't give us access to all the background data. So we need to rely on the results, and they are externally verified by a third-party person in environmental product declarations, EPDs. So we just have to rely on that data to be correct. The system boundaries that are included there, they should be determined by the standards, and they are determined by the standards. These standards, they vary a little bit across Europe and across the world, so that's a problem. But in general, they're quite similar for the products. But when we move on to the building level, there is a lot more freedom for the person doing the assessment. Even though we have some standards, they're very open and not very clearly determined. So they leave a lot of room for the person doing the assessment. And one of those things that is usually determined is the footprint, the functional unit that we compare for the whole building, but it differs across different countries, and like Rolf André mentioned here, that's of course a major one, but there are a lot of other differences, like the lifespan of the building, the study period that is used, the time horizon, and also of course which products are included. What parts of the building do you include? That. So if you only get the final result of, let's say, 500 kilograms CO2 equivalents per square meter heated floor area, as an example, that doesn't really tell you much, because then you get another result from another study, which is 700 kilograms CO2 equivalent. And those numbers alone will not tell you what was included in the studies. And therefore, you really need to have access to the data that was used, like the inventory of bill of materials. So if one of those studies, the one with 500, was including only the structural parts of the building, and the other with 700 kilograms CO2 was including the finishings and fittings and the windows and doors and the flooring and the screws, maybe even. And I haven't never seen that to date, but so it really matters a lot that when comparing studies, the system boundaries are equivalent or more or less equivalent.
What Eirik touches now is kind of utterly important, because when you do want to assess a building, you basically want to assess two things, kind of everything it takes to make the building, which is all the materials. And then you want to assess what is happening when you use the building. That is basically mostly the energy input. And then what is included in kind of making the building. It's very important. And as Eirik says, something you cannot collect everything. It's impossible. So very often you see that people are guessing, and very often they are not including the fastening systems or kind of the ventilation system, because it's very poorly described with data. So a lot of these metal parts is not included. In our case, in Norway, where we make a lot of things in wood, this is very important. So we end up kind of with not so good LCA. And then you start using the building, and then kind of, okay, how many years are you dividing this upon? It's really important. But also, are you using gas? Are you using electricity? And if you're using electricity, what kind of electricity do you count? Do you count the national one, or the European one, or the forecast one, or the yesterday one? And everything of this is important. And then you have different incentives. So if you want to put photovoltaics on the roof, you want to have the electricity as bad as possible to show how good you are, how smart you are to put these PVs on the roof. But if you kind of want to be on the cheap side and you don't want to insulate so much in cold climate. You want the electricity to be as cheap as possible, so you can say that, well, it's nothing to save on insulating better, etc. So it's very important you have strict rules on how to do this, and you also need to define all these things. And what we start with in the analysis is to describe the goal and scope of the analysis. And our studies shows that these are very often missing or not poorly described, I would say.
Yeah. So I just want to continue a little bit on that, because that's what a lot of my research has resolved around. So all of those parameters that Rolf André mentioned now is impacting the results a lot, and therefore it's so important to have the original assumptions that were made and the original inventory of all the materials, like what was all the basic stuff. So what was the quantity? What's the quantity of each material? What is the lifetime that was assumed for that material before it needs to be replaced? Also, the degree of recycling, if this product was reused, and so on. All of these parameters and more needs to be available for the study to be comparable, because if you have that, then you can just redo the calculation with a different building service life or study period or any of the other parameters. And that's kind of having the data on a uniform format for the different studies, and then redoing the calculations based on whatever assumptions you would like to make that make sense. That's what we're trying to do also in the software that we're developing at Reducer. So you can actually do many different assessments based on different methodologies. Let's say the Norwegian standard methodology or the future built methodology or the European taxonomy or levels method. You can redo the assessment for those different ones and get comparable results.
That's great, because I think nowadays we're at the point where maybe, let's say, project developers and investors are converging towards EU taxonomy, but still there's quite a big gap between what's happening in research related to building sustainability and what then practitioners are doing, right? So as you say, there are so many different methods and standards, and often I think they deliver different results. So it's important to have that in mind when you run an analysis. Another thing that I wanted to go a bit into better detail is when we talk about circularity, obviously the end of life is very important. And when you do an LCA for a product or even a building, there's a big difference between saying, oh, I assume that at the end of life of my building, everything will be landfilled or incinerated, or I assume best case and everything can be disassembled and reused. And that, of course, gives very different results. And I think maybe there's a challenge of moving beyond that and trying to inform people, okay, if there is an advantage of recycling and reusing the materials, but how do you actually achieve that, right? What do you think, what kind of information as data could we collect and store that can help people inform on that?
When it comes to circularity, this has been a topic as long as I've been in this business, which is since late 90s. What you see is that in general, there is a demonstration product of how good this can be every 5 years, and then there is not much happening. Although for some materials, this has been kind of systematized. So I know that in some countries, they have been good in recycling brick. Those countries has Denmark, Netherlands, Belgium, even Germany, at least parts of Germany. They don't have much natural rock, so they kind of they have a material constraints that kind of drives this. But then you also find that this is very difficult because it depends when you built the building you are going to recycle. If it's too new, it's impossible because you have used cement in the mortar between the rocks, and this glues so heavily that you cannot separate them. So this is kind of very difficult. So if you have old rocks, you can get them apart. But if you have newer rocks, newer buildings, you have to kind of treat it almost like concrete. You have to cut out panels and reuse, which makes it much more difficult.
That's fantastic, no? Like that we're trying to improve, but actually what we're doing through our new construction methods, that we're hindering the disassembly and reuse of materials.
Yeah, and that goes back to what I mentioned in the early beginning, that we kind of had 50 well-defined materials that we knew how to use and reuse 100 years ago. Now we have more than 75,000 different things that has small changes to them, so we don't really know what is recyclable, what is toxic, and what is. So just think of sealant on tubes. You have like in the store 30 different for the same thing, and some is good and some is not so good. So this is very difficult. And then you also have change in construction techniques. So we now want to have longer spans and more open rooms, which makes reuse of beams and elements may be difficult because they are too short. There is no way to make them longer. There's a lot of structural kind of hinders towards recycling. So we kind of should go somewhere maybe towards a standardization of widths and heights of floors, etc., or ceiling heights in order to get this into the system. But the problem now is that what we are talking about is already built.
Yes, definitely. It's that's a difference, right? Do we want to reuse our existing buildings in the future, or are we talking about making new buildings more circular?
I think we need to do both, but then we need to kind of map the existing building stock, and this is being done on various forms and with various purpose. But in the future, we're all dreaming of this digital twin where we can kind of select, and this is what our project are also about. How kind of can we understand this system so we can have some donor building there, which we can then take parts of and put into a receptacle building somewhere else. And I think this recycling is very good because towards renovate Europe, I would say, because Europe wants to renovate. At least I've heard this story for 15 years now, that Europe really needs to renovate its building stock. It currently is less than 1% renovation every year. In order to reach the climate goals, we have to be above 3% every year. We cannot make this with new buildings because then that will totally destroy the carbon footprint. But if we are going to do so, we have to be smart about it. And for Europe, I think the numbers are quite striking. They're going to at least reduce with more than 50% the carbon footprint of the existing building stock, that is energy use. And by doing so, they're going to renovate them, and they are going to create somewhere more than 2 million jobs in doing so, which is also very important. And now, also with the Ukraine crisis, it's even more on this because you can save a lot of natural gas import from Russia. So I think there will be a tremendous focus on this in the near future.
Mm-hmm. Well, maybe now we spoke so much about all the different types of information that's available and that's needed. Shall we maybe talk a bit about who should store this information and how should it be stored over the many years to come, considering that a building usually stands for, let's say, 60 to 80 years? Is this something that should be the responsibility of private or public entities?
Well, it goes back to the previous question also, that reuse, if the purpose is circularity of building products, then one thing is the reuse today, so reuse of existing products when demolishing or refurbishing a building. And the other thing is design for disassembly or future reusability. So reuse today versus future reusability. And for storing the information now, it is the future reusability that matters. So I think that building owners should be required to store the data about how it was constructed and how it can be disassembled, how the different products can be disassembled. And if we go back to calculations as well, and if it's designed for easy disassembly, then that will make it more likely that that product will be reused in the future. So that should kind of give some benefit in the calculation, so the likeliness of the product being reused in the future is increased. And who should store this data? Well, we could kind of say that it should be just centrally stored for all buildings, and the government will store all that. But we don't want to do that for our personal information, private information, and the building owners or even the manufacturers maybe of the buildings. They don't want that data probably to be given away to some central entity, so they would like to have it, but it should at least be required that it is documented. I don't know, what do you think, Rolf?
Well, I think that for a long time, the society has a strong interest in buildings, and that's why we have the cadastre, that kind of who owns what is the reach of your property, etc., etc. I think, as Eirik says, you don't want to store everything in the cadastre, but I think a lot of the information needs to be stored there so it can be kept kind of in a good way. But then you also have some concerns about this, in kind of what is the information there, and is it in everybody's interest to know your internal separation and layout of your building? Yes or no? But in terms of circularity, it's kind of very interesting to have as much as possible, especially about all the internal design, which wall is load bearing, etc., etc. So it raises a lot of questions. What we as a researcher want in terms of circularity is not necessarily what the lawyer or somebody else wants. Mm-hmm. So I think there's some work needs to be done there, but I think that a lot of the information should be somehow be connected to the cadastre so it can be used in planning. And this is also the digital twin approach, I think.
I'm in an office here next to another company that are developing kind of a central platform for building owners. So they kind of get all the data from operation and all the material use and the renovation and so on into one central platform. So it's kind of a digital twin, but with lots more information into that same platform, everything about the building. So the building owners want to have that data. They want to know as much as possible about the building, and then they can also automate the operation to some degree. So they want to have all that information, but as some of that can be required to be reported and openly available or stored centrally. A lot of it still is private to the building, I think, but some parts of it could be public.
Yeah, I think there's a big opportunity in building information modeling on BIM, because I think originally the idea was to use it more for, let's say, maintenance activities and to inform on that, but it has evolved to consider also other dimensions in terms of sustainability and material emissions, all of that. The question is maybe, do you think it makes sense to have such a detailed data repository for all types of buildings everywhere, or could that even maybe create more problems than it can offer solutions? Because again, this requires to manage the data over time.
We can start with the larger projects, but in theory, I don't think it's a problem to search for any building. The information is somewhere to begin with, like when the materials are first purchased. The information, most of the information is there already. It's just that we don't have a good way of managing it yet. So I think it's more about the technology becoming mature, so that not so much time is wasted on kind of inputting the data and so on. So I think that will come with time, but a good starting point is to require it from larger projects for, let's say, buildings above 1,000 square meters, for example, just as a good starting point.
Yeah, I agree with Eirik. We kind of need to start with the kind of large projects and the projects run by professionals. And I think that a way to build up this is to do it over time. So you don't try to do it for existing buildings unless they are changing them. So every time you want to renovate or make changes to a building, you should demand some documentation from now and onwards. Because I think it's not possible. But then there's big structural differences between countries in Europe. Some has kind of a high degree of personal ownership, like Norway, where kind of 80% own their own homes. But in other countries, this is totally opposite. Only 20% own their own homes. So real estate market is run by professionals to a different degree. So there is challenges in doing this in a kind of holistic way and transparent way across Europe. And then you also see the people moving between countries, if not to live there, but to kind of work and make buildings. We have a lot of non-Norwegian working on our construction sector, and I guess that is the same for many other countries. So you also have to agree not only on what data to store, but in kind of what language.
Yes, but maybe here the European Union can play a big role, no? I mean, of course, I know that a lot of construction workers come from outside the EU, but at least to come up with a standard framework, standard language for data storage and management that then can maybe be helpful also for communication inside the different countries, considering that the workforce comes from different places in the world. But one question that I really wanted to talk to you about is, you mentioned it before, talking about cadasters. So how do we move from having a detailed analysis of one specific building towards the city scale or looking at a full building stock?
Slowly, I guess. I think this is like eating an elephant. The only way to do it is to take one piece at a time. So I think, as I mentioned, you have to start with all new projects, either if it's a renovation or a new build. You have to select where to start and you have to start. And if we are lucky, I mean, if we are going by the current rate, we will be finished in 100 years. If we are going by the rate we need to go to, we can do it in 30, 40 years. But that's the time frame, because most of the buildings we are talking about is already built, and that's not going to change.
But so you would say it will be a bottom-up approach that slowly will fill in the gaps, product by product, building by building, and have a really big database that contains all the information then at a city scale.
I think it would be both a bottom-up, which I just described, but I think there also needs to be kind of some top-down where you kind of scan aerial photos, satellite photos, where you kind of do things. And
drones
then,
as well. Drones flying around, mapping the building, both
Good
indoors and outdoors.
Yeah, and then you will just kind of say that this is typically something from this period of time, and then you have average data put in. Just for kind of planning, because you need to plan these material companies that is going to do this recycling, reuse thing. They need to have a rough idea of what's coming. Otherwise, they will be too big or too small, and it will collapse on economic terms.
Yeah. My journey in research started actually with Rolf André Bohne. During my master thesis, he was my supervisor, and we had a really interesting topic that was top-down on this issue. So kind of what are the impacts of the city structure, the height of the buildings and the other size of the city, and the transport use and energy use and material use. So that was kind of a very top-down approach to the same issue. So maybe we can keep a same top-down approach and then fill in the gaps with all the new data that comes in from newly constructed buildings. And then also some new technology can help us with scanning the existing environment. I think there are huge opportunities there for combining both the top-down and bottom-up approaches. So I haven't seen Rolf in a long time, so it's really good to be back and discuss these things with you.
Same, Eirik. Same.
It's nice that the circle is coming to full close.
Yeah.
I think we've discussed a lot of interesting issues related to data for circular buildings today. I would like to close the podcast with one last question, and that is that if you could maybe recommend a paper, a podcast, a movie that is related to circularity or sustainability in the wider sense, doesn't have to be scientific, for maybe interest of our audience to learn more about this topic.
Yeah, maybe I can start on that. We are not talking about buildings, but building is part of the bigger picture. So why I'm interested in this is to kind of save the world, if you want, in a bigger context. And it's all about planetary boundaries. So that is, how much can we consume of space, materials, energy, and still having a green planet or blue-green planet. And for this, I came across some months ago a very good episode on Netflix, by all things. Johan Rockström, he's very good. He's a leader of the Stockholm Resilience Center, and he has led a research group that has investigated these planetary boundaries in all means and how dependent we as humans are on the ecosystem services in order to have a good life. And David Attenborough, another hero of mine, has teamed up with Johan Rockström and made a fantastic 75-minute episode on Netflix on planetary boundaries, where they basically go deep in and explain all these fantastic scientific papers in a very good way. So I highly recommend people to just search for Johan Rockström and David Attenborough on Netflix, and you will find it. It's fantastic.
Yes, I can support this. This is fantastic. Yeah. Thank you, Rolf. Eirik, do you also have a recommendation?
I'll just take Rolf's recommendation and have some entertainment this evening, I think.
Very good. Well, thank you so much. I would like to advertise also our next podcast. We will talk about policy and circular construction. Our guests will be Agathe Kuhn from Longevity, a consultancy in the UK, and Antonio Lorena, the managing partner of 3 Drivers, a sustainability consultancy in Lisbon. It was great having you, Rolf and Eirik. Thank you so much for your time. I hope you also enjoyed it. And yeah, see you next time.
This episode was written, researched, produced, and edited by Océane Sanglard and Verena Göswein. The podcast series is part of a Circular EcoBIM project funded by EEAGrants, Portugal, within the environmental program. The project is developed by 3 Drivers, Instituto Superior Técnico, Central BIM, Vic Properties, and the Norwegian University of Science and Technology.